Thanks everyone for coming along today. We have two great presentations lined up from David Williams, a site reliability engineer of PolarSeven. He'll be starting us off on spot allocation strategies for production workloads. We then have Dario Nascimento, lead DevOps engineer, who will be taking us through his learnings and experiences of building applications using the AWS CDK. So I'll start off by mentioning that we are recording today's session and we will be posting online along with the presentation slides later this week. Please feel free to use the Q&A feature throughout the session. However, we may take some of the questions at the end. There's also a chat bar on the right should you guys have any comments throughout. So the winner of this month's Amazon gift card is John Law. So congratulations, John, if you're on the call. A big thanks for your continued support and the feedback that you gave for us and everyone else who was able to give feedback. So you'll receive a follow-up email shortly. So next month, we will be hearing from Freshdesk, a leader in the ITSM sector, on what new technologies they'll be using within AWS and what they've been working on. So we'll update you shortly with more details on that presentation. We're also looking to book out the next financial year 21 for meetups, and always love to get speakers and content from the community. So if you or any colleagues from work have a topic, a project, or a demo that you might want to share, please don't hesitate to reach out by filling out the form. So a recent announcement from AWS, I'm not sure if anyone caught it, but a couple of days ago, AWS Code Guru is now generally available. So this is a service that we mentioned or highlighted at the reInvent Recap event at the start of the year, which got quite a lot of interest over. So this tool utilizes machine learning models that have been trained on several decades of code reviews at Amazon.com and over 10,000 open source projects on GitHub. So you can feed this into your application so you can get insights and recommendations to improve your code as per best practices with very little effort. So I highly recommend, if you haven't had a look at this already, go check it out, see how you might be able to utilize it within your applications. So I'll just briefly bring up a quick poll to make sure that everyone's awake and listening. So, okay. Poll number one is, do you currently use Spot instances? And it's a two-part question. So do you use Spot instances for production workloads? 3, 2, 1. Great. So I think it's as expected. So there's a few people using Spot instances, but much less people using it in production. So it'll be interesting to hear today from David to see how you guys might, oh, sorry, I just realized I don't think I shared the results. So most people using Spot instances aren't using it in production. So it'll be good to hear from David to hear of different ways you might be able to implement it. A second question just on CDK, just to gauge who in the audience is new to CDK. It's a relatively new thing that Amazon is pushing lately. Cool. So everyone seems to be relatively new to CDK, so it'll be good to hear from Dario about his experiences as well. So I won't take up any more time. I'll hand over now to David. So David, if you want to take over the screen sharing.
Hi everyone, it's good to be back again. As usual, lots of things happening in the Amazon world. We've got a presentation after me on the CDK, one of the new exciting things happening. And I'm going to give a presentation on some of the older stuff that's been brushed up and it's all shiny new again. So what we're going to have a look at is Spot instances. And if you're like me, I had a preconceived idea of what Spot was, and that was about 3 years ago, and it hadn't changed until about 4 months ago. So what we want to do is get you thinking about Spot and using it in production workloads, and not necessarily those that you do after hours, but ones like websites, etc. And start rethinking the auto-scaling groups. Use launch templates instead of launch configurations. So basically, if you're using auto-scaling for your workloads, you may well be able to use Spot instances. And then we're going to give a demo. So I'm going to demonstrate the what's called Spot allocation strategies in your auto-scaling group. And with Spot, you will get interruptions, very low level of probability to get interruptions, but you will get them. And so we're going to go over how to minimize those and then to handle those when they do happen. So let's do a bit of history on EC2 Spot. First instances came out around 2006. First service was S3, and then they moved on to EC2. And they were in the virtual world where there's elasticity and flexibility. At some stage, there's a hard boundary, and that hard boundary is the hardware. So in order to provide that flexibility, Amazon have to provide extra capacity. So it means they have a lot of hardware sitting around not being worked. Now, they won't tell you how much is extra capacity, but there's probably quite a lot there. Then more instances added. Today, there's over 270 plus instance types. In 2009, Spot was added to try and use up some of that spare capacity. So basically, we've got three ways to purchase EC2: on-demand, Spot, reserved instances. Now, you'll notice I haven't mentioned savings plan there because you can't use Spot with savings plan. So I haven't listed that there. And currently, there's more instances using Spot that were running in all of AWS back in 2014. So let's look at what we're not going to talk about. So this is quite a big topic. So we're not really going to talk about Spot fleets or how to use Spot with ECS or EKS, Fargate, EMR, but you can use Spot with all the above. When I heard you can use Spot with Fargate, I thought that's pretty cool. So what we're really going to focus on is the new properties inside the ASG, which are unleashed if you use a launch template. We're going to look at what a Spot pool is, and that's very important to understanding how you can maximize availability and minimize interruptions. So generally with Spot, when you start up a Spot, you want something to be available. And once you get that, you want that to be uninterrupted for as long as possible. So Spot pools will help you with that. We'll have a look at Spot pricing and probably why you don't need to look at Spot pricing. And the other thing we'll look at is the interruptions. Firstly, how to minimize, how to handle those, and then we'll have a look at when to use Spot, and then there's going to be the demo. The basic Spot overview is Spot is spare capacity. So if someone says to you, where do they keep the Spot instances in Amazon's data center? Well, they don't. They're exactly the same thing as an EC2. They're just a pricing and availability construct. Spot pricing, that used to be quite spiky. You had the bid, and then someone outbids you, then you would lose that Spot instance. Sometimes people were actually going above the EC2 on-demand price for Spot. That's all gone now. Spot pricing is now very, very stable and predictable. And in fact, you can go onto the web pages that will show you exactly what the Spot pricing is. Actually, you can see that within the EC2 console. There'll be Spot history, and you can see what the Spot price is, and you'll see it very, very little fluctuation. Interruptions. And now, because there's no bidding, the interruptions have decreased. And because of the changes in the ASGs, we can now have a lot more instance types to choose from. And so that means basically you need to be flexible with your instance types and sizes and availability zones. And the new changes to the ASG will enable that to happen. So Spot pools. What do we mean by Spot pools? Well, basically, every instance family or the instance size, availability zone, region is a separate spot pool. So we see here in this example, we've got C4, we've got 3 availability zones. So if we're looking at, say, C4 large, then we've got 3 spot pools that we can choose from. But if we start thinking a bit more flexibly about our instance families, we could use a C5 large, for instance, and that doubles the number of spot pools. We could also say, well, just a minute, let's have a look at my CPU and memory usage. Maybe I can use an M4. Maybe I can use an M5 as well. Again, each time you're doubling the spot pools that you can choose from. And really, if we said C5 or C4 large, we could actually use C4 extra large as well in our spot pooling. So we'll show you how that gets used later on. So let's get back to the spot pricing. This is like C5 large over the last 3 months. I haven't listed the actual price on here. It's for the most recent instance types. You'll find that the availability is less than, say, a C4 large, and the price, spot price, will be slightly higher as well. So more chance of interruptions, and you'll pay more for a C5 large. And you could use a C4 large, less interruptions and a lower price. Now, the thing is, with the bidding is now completely gone. With the UASG changes, you can set a maximum price, but the recommendation is forget about price and go for availability. So the spot allocation, and this is what we will be demoing, and this is set in the auto scaling group, but you can't set this unless you use a launch template. You have to use a launch template to do this. So the allocation, what it really means is that we want to choose an on-demand or a spot instance to run. So we can say, I want to have 2 on-demand as the base. And then I can add on either on-demand or spot, and I can adjust the percentage of each as I add them on. Or I could use all spot. And we'll show you what happens when we go from spot to on-demand. Now with spot, we have the choice of minimum price, which I mentioned, and the recommendation is to go for capacity optimized. And when I show you the demo, you'll see the different instance types which are chosen when you choose those two, make those 2 choices. Capacity optimized will mean that you will go to a spot pool that has the most availability, whereas a minimum price doesn't care about availability. It'll just go for price, and it'll go to a spot pool with a minimum price, but there may not be a lot of instances in that spot pool, and you've got a bigger chance of an interruption. Now for the on-demand, there's really only one option, and that's prioritized. And I'll explain what that means when we get to the demo. Now, inside your ASG, if you're using the launch template, you have a thing that's called an ASG override. So if we have a look, this is a bit of code. It's a little bit messy on the screen, but it will show you what we actually mean. As you know, in a launch config, you set your instance type, and that's it. You've only got the one, and that's all you can choose from. And that used to be the way with auto scaling groups. If you wanted to use a different instance family or different pricing, you would have to use a different ASG for each one. Now we can mix that all into the one ASG when we use a launch template. So we'll see here, we have our mixed instance policy, which you won't find in launch config. The launch template, launch config differ in that the launch config is a subset of the template. The template has everything in the config, but more. And so we can set here our launch templates, and we reference which launch template we're going to use, and then we can override the instance type that is set in the launch template. And you'll see there we have a list. Now, the order of this list is important, and we'll see why a little later on. So our first one is a T2 small, and we've got this new thing called a weight capacity. So I've set that to 1 instance, and then we've got a T3 small, weight capacity 1, T3A small, weight capacity 1, And then there's a T3 medium, and I've got a weight capacity of 2 on that. So as you know, a T3 medium will be double the size of a T3 small, usually. So what that means is that if we're using an auto-scaling group, we don't want to just bang in a T3 medium as an instance. So what the weight capacity means there, if we need to add in 2 new instances, we would then add 1 T3 medium only. And you'll see that it'll be much more obvious once we see the actual stacks when they're up and running. So the other thing that controls this, our allocation and instant distribution is on-demand allocation strategy. In this case, it's prioritize. What that means is that for any on-demand instances, they will use the first instance type in the list, in this case, T2 small. So that's, say if you're using reserved instances and you want to use Spot, you want to make sure you're using up your reserved instances because you've already paid for those. So you can set that prioritize. We'll use the first one in the stack, and we'll demo that later on. On-demand base is basically the number of on-demand instances you must have. So if you've got an ASG and it's running 2 EC2 instances and your on-demand base capacity is 2, then all the instances will be on demand. On-demand percentage above capacity, at that moment that's set to 0. So what that means is everything above the on-demand base will be a spot. So that 0 is the percentage of on-demand. And that'll be, we'll show that a little bit later on, with it actually a bit obvious. And the last thing is spot allocation strategy. And this is either the lowest price or capacity optimized. And we're going to go for capacity optimized. And you'll see we've got 3 availability zones. So when we're using these spot instances, it'll choose from 3 availability zones. And you'll see there's actually a lot more instances I've included, but there's only a few there. But every one of those is a spot pool. And that's across 3 availability zones. There you can see we've got a lot of instances that we can now use. So the chances of not getting an EC2 instance are very, very low. And the other thing is that we've talked about minimizing interruptions, but we cannot get away with 0 chance. Currently, it's around about 95%. It depends on the instance type. As I said, the more recent ones, your interruption rate will be higher. So to minimize that, we will use the capacity optimized. And also, if we have a lot of spot pools to choose from, we will also minimize the interruptions. Now, the interesting thing about this is that you might think, oh, interruptions, that's a bit messy, isn't it? If you're already using an auto-scaling group, you've probably got built-in fault tolerance, you've got in stateless applications. So using a spot and having it interrupted is not that onerous, because what Amazon will do is they will give you a 2-minute warning, and you can pick up that 2-minute warning and then take an action from that. And what we haven't done this today in the demo because we can't really simulate that properly. So what we're going to do is we're going to sort of simulate this, and you'll see what happens when we detach an instance from our auto-scaling group. So you get 2 minutes warning. That'll go to CloudWatch Event Bridge. You can then, from that event, that can kick off a Lambda function. There's a number of things you can do with that Lambda function, but generally what we would do is we would pick up the instance ID. We would then use that to, I'm getting a bit behind on time here. So we will use that for the, to run the Lambda function, and that'll detach the EC2 instance. So just quickly, minimal interruptions, 95%. As I said, if you're using auto-scaling groups, then you've probably got built-in fault tolerance. So is your workload spot ready? So basically, if it's stateless, fault tolerant, flexible across all AZs, loosely coupled, you're all set to go. And in fact, you probably build most of your applications that way anyway. So let's have a look at the demo. Now, I've built these with CloudFormation before we started. So what we'll do is we'll have a look at here. Now, I hope you can all see that. That's
Yep, that's fine.
I'll do this. There we go. Okay, cool. So what you can see here is that the number of on-demand instances is 0. Everyone's spot. The top one is spot optimized and the bottom one is lowest price. Now you'll see what's a bit strange here is that our auto scaling groups 10, 10, 10, and yet one's 4 and one's 7. And you'll see here, lowest price. Well, let's look at capacity optimized. Capacity optimized has got 1, 2, 3, 4, 5 instances, and yet we want 10. Now, this is because of the weighting. We had a weight of 2. So each one of these is worth basically 2 instances inside this auto scaling group. So this is going for capacity optimized, which means these are the most available instances that we can use that are in my list of instances, our spot pools. And with the lowest price, these are gone for the T3As. And again, we're going to mix some medium, some small. We've got 3 medium, that's a weight of 2. So that's altogether 6, and then 4 of those, and that gives us 4. So what we're going to do here, and we'll do it on this one because it's basically, it'll show a little bit better. So let's go on to our auto scaling group, and we'll choose this one here. That's the right one. Yeah, capacity optimized. No, sorry, I'm in the wrong one. What am I doing? Now, this just for the demonstration's sake here, let's just say that Amazon decided they want to take this spot instance back from you. They sent something to the event bridge, Lambda function kicked off. What the Lambda function will do is it will come in here and detach that instance. And it will set that to true, so it will add a new instance. And if we go to our target group, spot optimized, and we'll see immediately here that on the auto scaling group, this is draining. So no new traffic will be coming into that instance, and yet it's still going. So it's going to drain whatever's on there, and eventually then it will be terminated. So we can see now that's actually detaching. Okay. Yeah, okay. So this is basically coming up with another T3 medium, which is not really what I wanted. So let's, well, I want to show you 2 things here. Let's go to this.
Are the demo gods playing havoc with you, David?
No, I'm just running out of time. That was all. I talked too much. So what we're going to do here is, at the moment, on demand is set to 0. So we're going to set that to 2 and see what happens.
While this is happening, if anyone would like to put any questions in the Q&A field, just down the bottom, you'll see a Q&A field. Just put in any questions you'd like there. That'd be great. Thanks.
Okay, so look, this is what we can see is happening here. Now you'll notice with the capacity optimized, we've got a T3 medium because that's the most available. But we've now say we want to have 2 on-demand instances. Now the on-demand is prioritized. So that will get the first instance type in our list, which is a T2 small. And you can see now it's T2 small coming up. And what will happen is once these stabilize, it'll kill off one of the T3 mediums. So that'll bring it back to normality again. Yeah. So this one's initializing. This is the one we did when we detached the instance, and this is replacing that one. And once these stabilize, one will be deleted. So we'll come back to that anyway. So what we've had a look at is how to do the allocation. What happens if we interrupt an instance? Sorry. What's happening if we interrupt an instance with an event? And what happens when we put an on-demand instance onto the auto-scaling group? So it takes the first instance in our list. So what you can really see there is that this is behaving really like an auto-scaling group where an instance is taken out or you made some changes. You've got 2 minutes to drain the instance, that's the spot instance, and then that'll be killed off by Amazon. In the meantime, a new instance has come up to replace it. So really, depending on your workloads, I think for most workloads, this is not going to be an inconvenience. So the takeaways from this are be instance agnostic. Adopt launch templates, and remember that if you're using the newest instance families for Spot, you will pay a little bit more and the interruption rates will be higher. So you can go through and have a look at the instance types and decide, you know, the CPUs and the amount of RAM you want, and then find instance types that are going to meet that, and then add that to the overrides in your auto scaling group. And if you're doing architecting for fault tolerance and for making sure that you're stateless, etc., which you probably are anyway if you're using auto scaling groups, then you should be able to use spots. So there's a couple of links there. There's some good YouTube videos on how this works. And there's a blog on running web applications on Amazon. Now, some of these changes have been around for about 18 months, but the capacity optimized is a fairly recent change for this. So I think, you know, once you realize what this can do, you can really start to rethink how you use your workload and how you can save money, because this will definitely save you some money. So I think I've reached the end here. I'm running out of time. So do we have any questions?
Yeah, so there's just two questions. If you click the Q&A down the bottom, David. Yep, that one.
Yeah, got it. Yeah. Okay. Where are they gone? Where's the questions gone?
Do start new.
Click the start now button. New.
Down the bottom of the screen.
Oh, it's just, yeah. Okay. Oh, okay. Yeah, I can't see that. My laptop's in the way of my big screen. Here we go.
I actually haven't seen this tool. So David, I'm just going to read out the
questions.
Just read
them out. Yeah, sure.
If you could answer them. So from Sarat Dara, we've had in AWS region, what is the frequency of interruptions on an average? Do you have the stats?
Very good question. Now there is on the slides there is a website you can go to. So you just put in there spot interruptions and it'll take you there. What that'll do is you can put in the instance type and it will tell you the interruptions, which are normally around about 5%. And then we'll tell you what the average spot price is for that instance as well. So you can put a C5 in or a C4 and you'll see the difference. Usually it's around about 5% for interruptions, and spot price will go from between 70 to 80. It can go to 90, but mostly you'll see it's 75 to 85%. I think the C5 was down about 65%. Okay. Next question.
So second question is, how does Spot handle the ingress and egress internet traffic?
Same way as any other instance. Not quite sure what they mean by that. It's just another instance like an on demand. Or is he talking about when it's draining? Because when it's draining, it won't accept any new traffic. So draining means that the load balancer won't direct traffic to that EC2 instance. So any processes that are running, that are processing so previous data coming in, they'll finish. Hopefully, depending on what your workloads are. So that's some sort of area you need to to look at depending on your workloads. I hope that answers the question.
Okay, great. And David's email is on the last slide, so if you have anything follow up to that, feel free to send an email. There is a couple more questions just with the interest in time. So we'll just do one quick.
Yep.
So with 2 minutes to interruption, is there a way to take a backup of the spot instances?
Yes.
Launched with the backed AMI?
Yes. Yeah, now that's an option I didn't have a look at because there are so many options with this. We just demoed that. You can put the, with the spot instance, you can put it into hibernation, you can take backups. What we've just done is we put it in the draining. We don't really care because it's faultless and fault tolerant and stateless, but you can back it up if you want. Depends really how you want to do it. So you do have that option. See, the Lambda function that we use just does the auto scanning group, but in that Lambda function, you could go and back up the data. So yes, definitely. And there's another question.
Look, we'll just, with essence of time, if
we're running out,
an extra minute at the end, we'll just come back and answer them. If not, we'll follow up with something answering the outstanding questions.
I talked too much.
Great.
Okay.
Thanks a lot for that, David. It was a great presentation. So I won't take up any more time. I'll hand over straight to Dario. So Dario, if you want to take over presenting and jump straight into the CDK.
Thanks, Jackson. Can you hear me? Can everyone hear me?
Yep, loud and clear. Okay.
Hello, everyone. Good afternoon. I hope you are safe and well on these unique times. So today we're going to talk about Cloud Development Kit, or CDK, which started being developed by Amazon 2 years ago, and it's promising to revolutionize the way we interact with cloud nowadays. You probably saw this slide like heaps of times already about DevOps, the classic about application logic and operations teams. But one of the main gaps between these two teams is that the developers have all these nice languages that are functional programming, or imperative programming, or object-oriented languages. And they have all the nice features that those languages have over the last 20, 40, 50 years of development. And they are rich, they are easy to read, and it's so easy to develop and compile them and make sure that things work. While the teams on operations, we keep insisting on using declarative languages, such as YAML and JSON. And while these languages are quite nice to read as a per line basis, it's pretty easy to understand what type AWS S3 bucket means. It gets very difficult to read when you have CloudFormation stacks with like 1,000, 2,000 lines of code. And this becomes more of a machine kind of task. And what Amazon started to realize is that there must be a better way. We're not gonna write a JSON file for every time we need to call an API. That will be crazy to do in a programming world. And so the AWS Cloud Development Kit ends up being a software framework to define cloud infrastructure in code and provision it through CloudFormation. And many of you are now like thinking like, oh yeah, but we had already so many options on that area. What does CDK bring in? So one of the major difference between CDK and the other configuration management tools is that CDK is based on programming languages. So you're actually using TypeScript, Java, Python, and other programming languages to define your CloudFormation stacks. And the flow as it goes is pretty simple. And by being simple is also pretty rich and pretty well extensible, which is very interesting. So Amazon has this tool named CDK, which is a binary that you execute in your environment. And just to begin, one of the nice things that they developed was CDK init. And so CDK init brings you in a scaffold of your project. So by doing CDK init, you get pretty much a template of your project and a quick bootstrap. So you can directly do CDK init, CDK synth, and CDK deploy. And you have straight ahead a CloudFormation stack that's being deployed. And this may not be significant for small organizations, but in a large scale, having templates for developers to start having a better cloud user experience that's very meaningful. And so this CDK need create a project template. And this project template, one of the examples will be, for instance, TypeScript, allows you to define what Amazon calls constructs, or you can see them as objects in an object-oriented programming language. So these constructs are your RDS, your Lambda functions, your load balancers, your S3 buckets, and all the kind of Amazon native resources you can define. And you can do this in a programming language. So we have all the if, else, all the richness of those languages, being able to call external functions to get more information. You can do all those kind of things. But then you do CDK synth. And what CDK synth does is it compiles your application, your source code, into CloudFormation assembly or JSON. And why this is so important is because if you go through an application that's written on imperative code, let's say C, for instance, it's very difficult to reason about what's the end state of your system. It's very difficult to understand what the application is actually doing as an output. But if you go to a CloudFormation stack and you read a YAML file, you know that's the desired state of your application. You know your S3 bucket should have the name X. You know that your S3 bucket should have a retention period of X amount of days. And that's the goodness of the declarative languages. So the way you can see this here, and you will see why I call it assembly, is that you can pretty much having your source code flexibility, but you still get the goodness of having a declarative language in YAML that you can see and reason about the end state. And the next thing that tool allows you to do is to do CDK deploy. So if you want, for instance, doing development and just do quick prototyping, that's great because it allows you to just pretty much managing CloudFormation from your machine in a very, very easy way. And then if you want to wrap this tooling in a code build, or if you want to wrap it on Jenkins, TeamCity, wherever your CI/CD flavor is, you can simply use it out of the box. So this is how an example of code from CDK looks like. And you may see straight ahead, it's very, very different from a typical YAML file. On the top layer, and I'll go into detail during the demo on this, you can see the stack. So we're defining a CloudFormation stack. And then the first thing we do in this line of code here is we do new S3 bucket widget store. And for those who have some fun time writing CloudFormation stacks every day, of which I also include myself, it gets very dense to write those CloudFormation stacks and having to go through the documentation and all the fields. And you can see straight ahead here is like S3 bucket, and that's it. I don't declare a name, I do not declare any retention periods, anything. So what they built on CDK was different layers of abstraction, and I will detail about them in a second. And the other bits you see here, just for sake of components, is the Lambda function declaration. Are we granting access to that bucket, to that Lambda function? And we added that Lambda function to an API gateway. And I'll detail this in a second in our source code. But moving back again to the S3 bucket, you can see here that I'm just saying I need an S3 bucket and that's it. And then I'm saying grant access to it. So what Amazon did when building CDK was what the best developers do when they build their applications. They build layers of abstraction. And that's why programming languages and computer science in general can be so powerful. So our assembly is a CloudFormation. It's pretty much the raw data that we want to obtain to deploy to the cloud. And then what the CDK team and the community did in general is they wrapped the CloudFormation in an opinionated fashion, and they built constructs. They built pretty much classes that are simplified about those CloudFormation. So for instance, in the case of S3 bucket, you would expect to have a curated layer that says pretty much new S3 bucket, but the constructor of that class has pretty much a name generator, some opinions about retention periods. So they built a lot of opinions on these abstraction layers. And by the end, the nice thing about this is that you can also build your own opinions. So you can create patterns. So let's say I have a pattern in my organization where everyone does a stack with API gateway, a Lambda, and the RDS database. I can create a template. I can build that as a library. I can publish that to an NPM or to a pip repository. And then I can have people across my organization to leverage the patterns that we built within the organization. And that allows you to start doing proper DevOps. It allows you to have people defining detail of code formation, and the same people that build the source code, they do the functions themselves, like they code the Pythons, the Javas, they can use the same programming language to leverage your patterns from the infrastructure. And so we become this pretty obvious, I think by now, if we think about this pretty obvious agreement between people developing infrastructure patterns and people developing source code. So they can have a clear interface with each other based on libraries, which are versioned, which are compiled, and have all the goodness of using programming languages. And so this is pretty much a summary of that. So we have strongly typed programming languages, which is amazing because, again, if you develop code formation stacks before, you know how painful it is to know if your arguments are correct, or if it's a true, if it's a false, if it's string, an int. So it becomes a strongly typed construct. So there's already some guardrails. And because we're leveraging a programming language, we can have all the benefits of IDE. So we can have code completion, we can have easy access to the code implementation details. Amazon was super nice and added also links to the documentation in the source code. We can leverage the libraries that I told about before, so the community libraries. You can compose and share your own libraries. And then the other thing that developers probably always envy the operations team is you're doing such a critical job on changing your code infrastructure, yet you have little to no test usually around your systems. So the CDK, as a programming language, brings you in the opportunity to do unit tests. So you can actually use the common unit test tools for programming languages to test your code formation information. And as developers, we can do a lot of automation on that. And it also uses a lot of good patterns by default on code formation. So for instance, using change sets. And the last bit, and not least important if you have people who are more security minded, is that you can do fine-grained assertions on this. Because you have to have your source code on your application being compiled to a code formation and then being deployed, one of the nice things about CDK allows you on this framework is that you're able to create assertions. So for instance, you can make sure that everyone compiles to a code formation that has encryption enabled, so that people are actually doing the right thing and using the right patterns out of the box. And the last nice thing that I didn't have here about CDK is that although it sets some patterns and allows you to set some libraries, it still allows you to go into detail and fix things. So let's say I have a code formation that is created by an opinionated library, but that opinionated library does not create the code formation in the manner or with the parameters that I want. So I can, after compiling to code formation, I can literally go and modify the code formation YAML file and say, okay, I want this parameter to be a different parameter. So you have some flexibility to go and change your Ansible code as well. And the last thing is, if everyone, to everyone who developed code formation before, we all know how code formation falls behind the Amazon APIs and how many times you have to do custom changes for that. And CDK did a nice job as well on wrapping those, so they can have custom changes done in CDK, and then CDK creates the custom handlers in code formation to perform those changes. And you can do all these things in these programming languages: C#, Python, TypeScript, JavaScript, and Java. Now, although it looks pretty on the design of the slide, there's a reason for me to highlight the C#, TypeScript, and Java. You really want to make sure that you use a typed language to do this. I do not see much of a benefit for using Python or JavaScript on CDK, because to my belief, one of the best things you can do is to have types on your language. and you can do all the enforcements that a strongly typed language allows you to do. So please, if you're adopting CDK, Amazon current recommendation is TypeScript, and you don't need to be an expert on TypeScript to know how to do it. It's pretty easy to start declaring your CloudFormation stacks in TypeScript. And with all this said, let's go to a quick demo. So this demo in particular will be quite simple comparing with previous demos I had in this forum. This demo is also actually available as one of the examples on the CDK website of Amazon. So please make yourself a favor, give it a try on your machine. It's pretty easy to use. But yes, after running the CDK init, you'll get this project structure. And for all the JavaScript fans, you have a package.json and all those things. But for us, the main interesting ones are the binary directory where I have my widget service. So here I'm defining an app. Every single CDK is composed by an app. And there's a lot of things I could say about that. For instance, one of the things that CDK allows you to do is to define several environments and accounts in which you can deploy your app. In this case, I just have one simple environment in Australia. But then the app is composed by stacks. So here I'm importing a stack, my widget service stack, from this library, my service stack. So we're going to open this service stack. So this is a class that extends CDK stack, and this stack is composed by a service. We call it widget service, which is imported from a different library. So right ahead here, you can see how easy it will be to compose several services within the same stack, or how easy it will be to compose several stacks within the same application. Going to the widget service. So this is a construct. So this is an object, as I mentioned before. And this construct, this object, has several other constructs, including composing it. So the first is just an example that I have it committed, is the first layer of abstraction on CDK. So all the base layer of CloudFormation abstraction start with CFN, so CloudFormation. And you'll see like this will be pretty much similar to do a CloudFormation. So you have availability zones, associated roles, delete protection. So it's raw data, it's like your symbol. The next one is an S3 bucket, as I mentioned demoed before. A lambda function that creates a Node.js, a container, and this Node.js application is going to run source code in the resources folder, which is this function here, this widget.js. And I'm running access to this lambda function to the bucket, and I'm adding these to a REST API and API gateway. So CDK team also built some nice wrappers around this. So you're able just to define a resource, and you're able to define pretty much a CRUD API to that resource in a very, very easy manner. So these are what, like 64 lines of code. So the next bit we'll do now that you have this nice source code is we're going to compile it. So to do so, I will run CDK sint -v, which is just a make it verbose. So CDK is just connecting to my AWS account, making sure all the configuration is correct. And there's it. So those 64 lines of TypeScript, they resulted in all these YAML file on all these pretty much CloudFormation. So we have an S3 bucket, we have an IAM policy, which is, as you can see here, is well curated from access perspective. And we have the lambda function that we mentioned before. We have dependencies between them created automatically. A CloudWatch role, two stream roles here. We have an API gateway account, API gateway deployment, API gateway stage, and the list keeps going on, and methods. So it pretty much, all this CloudFormation was generated based on opinions of the CDK team. And now if I trust this, I can just simply do this. CDK deploy -v. And what CDK is going to do is just going to upload this CloudFormation, and it's going to run CloudFormation to deploy it. But before that, it does something that's very interesting, and I really like it. Because a lot of opinions change the IAM roles and the permissions that you have on your account, CDK does this pretty amazing IAM statement changes. So I know exactly what resources and actions, effects, and the principles are going to be able to perform after having these CloudFormation changes going on. So it's a good sanity check to verify if I'm not allowing access to something I don't expect. However, the nice thing about this, you can see how well created the permissions are. So this is a good step forward for people to stop using admin roles for everything and starting actually having good patterns from a security perspective when consuming cloud. So yes, I agree with these changes. And now CDK, well, we're talking CDK will be uploading the CloudFormation stack and we will be deploying it. So we can go to our Amazon console in old fashion and we should be able to see creation in progress. It should sound pretty standard for most of the audience. We have a change set that pretty much has a summary of all the changes that were performed at this time. And you can see how large this template actually is. So because we are able to start using programming languages correctly, we are able to start hiding the complexity of consuming cloud and starting being able to simplify and abstract the cloud itself. And if we go back, we're just waiting for the completion to happen. And I'm just going to open API Gateway. And here we are, widget service, ID, still creating more stuff, I believe. Yeah, creating. So you can have all these nice logs as well, so you don't need to log in the console and see what's happening. Creation completed. We'll just wait a bit more. And the nice thing, well, this is completing. The nice thing about the CloudFormation, as I was telling, is that even I created these as a TypeScript application. Even I created it as a TypeScript application. The other people in the teams or other developers can just even go to the declarative state and see actually what did I create. So in a large scale environment, I really should not have to care about being TypeScript, about being Java or any other programming language, because all of us are going to converge in the same assembly that's going to be compiled and deployed by CloudFormation. So by now, should have all the things created here, and there we go. So we have the ID, delete, get, and post available on our API Gateway. And we come here. Yep, that's it. So my API Gateway is deployed, and I have here the URL to access it and my stack resource. That's it. Pretty much the main message I would like you to get from here is that see this as an evolution we have in computer science from going from Ansible to programming languages, but similar happening now for cloud consumption. So layers of abstraction and being able to share learnings and being able to share the libraries across multiple people within your organizations and across all the organizations, across all the community. Thank you very much to everyone. Hope you enjoyed and open for questions now.
Yep, so can you see I'm hesitant to go into that page again, so I'll read them out again. So from Vincent Choi, does CDK deploy implicitly call CDK synth, or do you need to synth all the time?
That's a very good question. Just right before this demo, I was double checking that. I figured out that if you do build, it actually compiles the CDK stack and you need to do synth again. But if you don't have run CDK synth before, you can just do deploy automatically.
Okay, perfect. Great. Thanks, Vincent. Another one from Vincent while we're at it. So any strategies to force CDK deploy stack against resources that were touched/modified manually via the AWS console?
Great question, Vincent. Business as usual, almost. So CDK itself does not have a specific policy on that. We still have to use the CloudFormation Drift platform pretty much. So CloudFormation is what has still to manage the drift between the desired state and the existing state. So there is no specific on CDK deploy for that. How good is the official documentation for CDK? I found it quite good. I found like the getting started and examples are solid and it's able for you to start. However, I think the nicest thing about being CDK is this, like, I love the fact that I'm able to simply do this thing. I can just come to my code, S3 bucket, I press in, okay, cool, this is a constructor. Let's say, for instance, a bucket. I can just go and read the code and actually can see exactly what's happening in the detail. And because this code is not complex, like you're not talking about complex algorithms, this is pretty much generating code. It is pretty easy to debug. And I didn't try Stack Overflow that much, fortunately, so far. But the nice thing about that is the community on the Git repo for the AWS CDK is very active. And they are always ready to help you on questions, which is very good. So I'll pick Vishal first because I think he had the question before. Or maybe just a timestamp thing. So how does CDK compare against Pulumi? So I met the Pulumi founder 3 years ago before CDK became a thing, actually. And it was like just a PowerPoint slide deck at the time, actually. So Pulumi extends a bit more than CDK. CDK is just a CLI tool, while Pulumi, they have a service offering platform, so a SaaS. And they also targeted not only Amazon resources, like just AWS resources, they also target other cloud vendors. And they also target native resources such as Kubernetes, for instance. So I would say that Pulumi currently has still a significant competitive advantage if you are on multi-cloud. In the case of CDK versus Pulumi itself, only for AWS, I'll say CDK is going pretty well on getting more mature, so give it a try. Is there any framework built on top of CDK? Abhinav. So the idea here is that I'm not aware of any existing framework built on top of CDK. The idea here is like, why don't you do one? So the idea here is that if you have an organization, if you have people that you collaborate with, please build your own framework, build your own tooling, build your own patterns within your organization. The idea of CDK is just to be the Lego blocks that the builders will be able to compose to build larger partners that other people can leverage as well, and then compose those patterns and build larger patterns and so on and so forth. That's the idea. So you have a challenge here. Build your own, build a framework on top of CDK with more patterns and share with everyone else as well.
Great. I think that's everything in terms of questions. So we'll just wrap up now. So a big thanks, Dario and David, for presenting today. We will be posting the recording and the presentation slides at the end of the meetup, so you can also view past sessions at our website at your own leisure. I'd like to just quickly finish off with one more poll just around how you guys enjoyed today's session. So on a scale of 1 to 5, how would you rate today? 5 being very satisfied. Just give it another 10 seconds. Great. So thanks everyone for your feedback. And again, if you've got any presentation or topic ideas or just other things you'd like to hear about from the group, please do reach out. We would love to hear from you. So thanks everyone for coming along today and continuing to show your support for the community. We hope you guys can make next month and that you stay safe with everything going on. So thanks Dario, thanks David. Hope you guys all have a great night.
Guys, that was great. Take it easy.